to a new episode of the podcast, TheBlueShift. I'm Professor Rodrigo Riera, and today I'm so glad that we got another researcher that we are going to interview about ocean-based solutions to mitigate and reserve climate change. And here today is Laura Marín Samper. Thanks a lot for being here.
Thank you.
Laura is a marine biologist that is having, defending a bachelor degree in UK, and then you're going to move to Hawaii. Oh, I'm so, really envy about that, to do a master. And now you're currently a Ph.D. Student working within a group, EOCAG. This is about climate change group. You develop further when you're talking about it. And now this is your PhD is about one process about mitigation of climate change. It's Ocean Alkalinity Enhancement. And could you explain a little bit further, what is this?
Yeah, sure. Well, first of all, thank you for the introduction. I'm currently working in Javier Aristegui's group here at the university, which is part of the EOCAG, as you said, and it's called Biological Oceanography Group. And we have this research branch focused on negative emission technologies or carbon dioxide removals, as they're called, right? CDRs or NETs, in case you ever heard of them. And Ocean Alkalinity Enhancement is one of the newest negative emission technologies, or CDRs, that have started to be researched on, and it's basically based on capturing atmospheric CO2 as in its inorganic form in the ocean. So basically, what we try to do is we try to mimic the natural mineral weathering process that already captures about 1.1 gigatons of carbon a year.
A lot.
Yeah. So we want to accelerate that process that occurs naturally to human relevant scales. And in this way, basically, so to do that, what we do is we add minerals or mineral-like compounds that increase alkalinity in the ocean. And what that does is that it pushes the carbonate chemistry equilibrium away from the CO2 and into a more stable and harmless a species of carbon that's bicarbonate and carbonate ions. So basically you have CO2, a carbonic acid, and carbonate and bicarbonate. And when you add alkalinity, what you do is you push that equilibrium away from that CO2 side and into the carbonate and bicarbonate species, which allows for more CO2 diffusion into the surface ocean. And that's basically what we're trying to do.
Okay, yeah. I got a really good question, but I'm feeling that we're starting the house by the roof. Okay, but maybe what about this ocean alkalinity has been done in a really small scale, like a pilot scale? We are talking meso scale, or even in a larger scale. What is about the potentiality of this solution?
So, I mean, it needs to be. So the goal is to and it seems that it likely has the potential to be implemented at gigaton scale. As of now, so it started with modeling. It was first proposed in 1995.
Okay, so recent, yeah, okay.
Very recently, and this was like a theoretical article, right? Then from then on, and after there was more investment on land-based, then it started to be ocean-based CDR that became more like, that's now getting a lot of attention. But for ocean alkalinity enhancement, it started with modeling studies. Then there was a couple of lab studies, with one on a reef, but more focused on the mitigating ocean acidification, which is a potential co-benefit of it. Then testing its actual CDR potential. And then there was a few lab studies. Then we did the first, we in collaboration with many other people.
Even especially we are talking about German research teams, right? That Germany is, I think, is on
it's a hub. It's a hub
around. It's on the way for this kind of technology as well.
Definitely, yeah. Okay. So actually, the first project that was funded by the EU to research ocean-based CDR was OceanNETs. It started in 2020. That was actually how I started here. And it funded two mesocosm experiments. The first one in Gran Canaria, which was actually the first in the world to test ocean alkalinity enhancement at that scale. I mean, mesocosms are like this kind of like this really large tanks. That and it's not really a tank, it's like a long tube.
The tubes, okay.
Right?
And you got another one like a bubble, right?
Yeah, but
Okay,
that's
this
it's
is like
actually underwater. It's like a
underwater.
tube,
Okay, like a tube.
and it
Okay.
has like a sediment trap at the bottom.
Okay. Yeah.
So you can kind of check for like the carbon export with actually sediments, and you
Yeah.
measure that. You measure all aspects of the ecosystem, right? But then you have like the little covers that you put on top to avoid anything going in. That looks like a bubble. So
A bubble.
it's
Yeah.
kind of like
Okay.
floating
Sounds
bubbles.
good. Yeah.
But underwater, they're like these tubes that what you do is basically enclose a piece of the water column with what you're interested in. Basically, if you have small means maybe 8 cubic meters or 6 cubic meters of water, which is a lot, then you filter out fish, for example, because they're too large, but you have all the plankton community.
Okay.
So zooplankton down to heterotrophic bacteria, all of that in that water column, the natural community, in the natural conditions. And then inside, you change the conditions based on what you want to test.
And this kind of experiments you could do in the premises that we got here in Gran Canaria. Is it possible?
Yeah.
That one. And have you done that before? Yeah. Okay.
Yeah, definitely. They've been doing mesocosm studies for many years.
Okay.
The first one in the whole world to test ocean alkalinity enhancement at this scale with this volume of water with a natural community was actually here on Gran Canaria in 2021. And then there was these mesocosms were 2.5 meters or 3 meter depth. I might be in depth. I might be wrong there, but it was about like a few meters. But then we went to Bergen to do another experiment within the same project, OceanNETs. And those mesocosms, they were like offshore mesocosms, Cosmos units, and they were 23 or 22 meter in depth.
Oh, okay.
So there's different scales within these mesocosm experiments. But they were the first ones to actually test this ocean-based negative emission technology, or CDR, not in situ, because it's not exactly what would happen if you actually dumped that amount of alkalinity into the ocean. But the more, it's like an intermediate, right?
Intermediate.
The closest we can get to actually.
Yeah. And I can see, the difference between different coastal environments. For example, in Norway, in Bergen, you have fjords and this kind of stuff, really constant and stable conditions in oceanographic terms. And maybe, for example, you would like to reach like a depth about in the range of 25, 30 meters, you have to go almost a mile offshore here in the Canaries. So maybe the conditions are really different because the connectivity is huge, the ocean currents, tides, and this kind of stuff.
There was actually a failed experiment in 2017 in the Gando Bay, but they repeated it and it worked out fine. So, I mean, it can be done, but it's way more challenging for sure.
And what about the results of these experiments? You can see there's a kind of, you can see some light at the end of the tunnel. Is it good, or quite optimistic scenarios in the near future for future experiments or not?
It looks great, actually. I mean, in terms of environmental impacts, it looks like at least within the range that it's reasonable to expect, like in terms of alkalinity, right? So if you enhance alkalinity, you can do it in different ways. If it's in an equilibrated way, which means that I add alkalinity, but before I add that alkalinity, I offset that, I add the CO2 that I turned into carbonate and bicarbonate ions, right? So if I do that, what I'm adding is alkalinity, which is neutral. It really has no impact. It has no effect on on metabolic processes or anything. It's really pH or PCO2, right? The substrate for photosynthesis that can have a real impact, maybe. If you compensate for that before adding that water, right, then you basically alter pH a little bit and increase GIC or alkalinity a lot, but CO2 and pH stay relatively stable. So no impact, you would think. But if you add alkalinity and don't compensate for the CO2 before, or sequester the CO2 before adding it, then you reduce CO2 in the water column. And if you leave it to re-equilibrate, it can take months to years. So what you're doing is you're limiting, in theory, you could cause phytoplankton growth limitation, right? And we've observed that, but at ranges or at levels, PCO2 levels, that are very, very low. So actually, phytoplankton seem to be resilient. So phytoplankton are like the base of the trophic chain in the ocean. So it seems like they're resilient to quite low PCO2 levels based on these experiments. Now, the community composition of this phytoplankton is a little bit more complex, and it can be altered a little bit more easier. But if you think about adding alkalinity to the ocean without the cosmos, without the mesocosms, then really the changes that to these carbonate chemistry parameters, like CO2 or pH, they're probably going to be a lot more transient, right?
Yeah.
You don't have a stable reduction in CO2 for months because it's just going to dilute very quickly.
Yeah. That's for sure. Okay.
So that's something that we need to check, because if it dilutes that quickly, then you don't really, you might not have such a gradient between surface, ocean, and atmosphere, and maybe that CDR efficiency or carbon capture efficiency or carbon dioxide removal efficiency is lower than we think. But in terms of impacts to the community, it looks good. It looks like phytoplankton, and at least that's what I'm doing. And zooplankton seem to be quite resilient to levels that...
Sounds good. You are right, it's a really good point, because I got a batch of questions, because I think it's so exciting, you know, this topic. We are talking about how does, you know, the alkalinization interact with the natural carbon cycle in the ocean? Because I think most of the people are a little bit aware when you are trying to disturb, you know, the natural environment, something is going to have like a concomitant effects, or maybe like a secondary effects because of you put your hand in on this environment. What about the implications of the natural carbon cycles? Are there any or not?
I mean, you mean like in terms, like of course you disturb the carbon state, the carbon equilibrium. But if you think about the natural carbonate system at the moment, right, it's being directly affected by climate change, and it has the consequences like ocean acidification, right, and what that entails for organisms. So yes, in that sense, we can mitigate. One of the aspects or co-benefits of this ocean alkalinity enhancement is to mitigate ocean acidification, at least regionally, because it's very unlikely that we will reach, you know, a scalability that's like large enough to reach like the goal of, for example, reducing CO2 at a global scale in the ocean to pre-industrial levels, which would be the ideal scenario. And in that case, of course, there would be relevant effects to the natural carbon cycle. But then there's effects to the organic pool of different components for sure, because you're altering indirectly some organisms in the at an ecosystem level that have an impact to the carbon cycle. But because adding alkalinity to the ocean, it would have impacts at a very regional scale. These impacts are not that massive. Right?
Okay, sounds really good. And this is to have like a meaningful, you know, climate impact. This process. What is the scale that we need to reach for this alkalinization to see real effects of, you know, climate change? I know that the effects on climate change maybe takes like decades or even centuries. That one, but you need how the Paleolithic society is always asking for something urgent to fix it. You know, what is I think we need a scale, because I saw there's a couple of papers about talking about afforestation, about just trying to growing extensive, you know, fields of algae in the middle of the ocean, in the open ocean, that maybe it takes like maybe the size of Belgium or even Holland just to have a real effect on climate change. What about in this process, alkalinization? Needs to be massive as well or not?
Yes, definitely. It needs to be quite massive, and I think that's one of the main challenges that we have at the moment. I mean, what you're saying, the good thing about ocean acid alkalinization is that it not only mitigates or could potentially mitigate global warming, it can mitigate ocean acidification locally. So that's like a positive side of it. But in terms of to have a temperature, an effect on temperature, you would need capture at a gigaton scale, which is very, very, like a lot. Okay. I think it was like this reference is like 1 gigaton of CO2 is like if you think about several football pitches of CO2, you know, like it's just a massive amount. It's like the historical emissions of the United States and India together or something like that. So I think that if we are to reach that goal, that's only if we actually reduce. That's the goal. Like
Yeah.
you need to reduce emissions. I cannot emphasize that enough.
Yes.
And then you can use these technologies, and not only ocean alkalinity enhancement. Ocean alkalinity enhancement has a lot of potential, and it started to be implemented regionally and in a few locations around the world. It's already being used, and it's being researched. And the CDR potential and the monitoring and reporting verification of all these carbon capture is now being researched. So we don't really know, right?
Yeah.
How, at what scale it will be able to implement.
Yeah, but I think that one of the best advantages is you could together simultaneously with other actions, like maybe blue carbon, preserving like mangroves, seagrasses, even rhodolites and this kind of stuff, and also, for example, doing afforestation. So
and
different
DACs
technologies.
and BECS and CCS and macroalgae cultivation and sinking and all of them together. It's like a global effort, and it needs to be very interdisciplinary. So, I mean, ocean alkalinity enhancement is very new. So it's a very early research stages. And of course, with the information that we have right now, it is hard to know how far, at what scale we will be able to implement it, right? Yeah. But the potential is there. Yeah. So, and the work is being done.
Yeah, I think it's a really good discussion, because maybe sometimes we need to change the idea of the public society, that there is no panacea. There is no only one plain solutions for these huge problems. So maybe just having like articulated certain solutions, partial solutions, together with the way we're living, that we need to check out really carefully about what we have done and we are doing at the moment. Maybe we need to change, certain, topics or costumes that we got that are not really good for the climate. So I think a huge potential in this area for that one. What about, for example, for these alkalinization projects, what is the funding schemes? Is there involved private companies? There is also the term about blue carbon credit, and I'm not really 100% fan of it, because I think it creates a kind of tensions between countries and economies. We need to really look carefully about that. But what is these funding schemes or maybe funding projects have been done mostly surely about with public research institutions, right? Or is there any like a huge lobby company or a huge company that is really digging into this aspect or not?
I mean, so as of what I know, right, the carbon credit market scheme is affecting all nets and CDRs and nature-based solutions and all of them. Like the idea of generating carbon credits that can be bought by companies. That I feel it's a bit perverse, right?
Me too.
It involves the private sector a lot, at least for OAE, for Ocean Alkalinity Enhancement. It started being funded by the public sector, almost exclusively. Now there's this really large project, Ocean Alkaline, that funded 3 mesocosm experiments last year, and another one this year. Now they're coming back to Gran Canaria, by the way, in a couple of weeks. And that is kind of, they have private companies or startups that are investing in researching ocean alkalinity enhancement with the goal to commercialize carbon credits from it, from the carbon that it captures. And there are many startups that are starting.
Yeah, for sure.
Right, in this field. Yeah. But again, I mean, it kind of promotes the business as usual scenario, and we need to be very, very careful in the next few years, to make sure that we're not selling smoke first, right?
Yeah, right. Yeah.
And second, because these technologies, not only OAE, blue carbon, any other strategy that can be used to mitigate climate change, should not be used as an excuse to keep going in the business as usual mode, right? We need to. This is why I mentioned this in the interdisciplinary aspect of this world, right? We need to have social scientists, anthropologists to study public perception. We need people that look at the economic implications of these field, right? And how it can be regulated, so that we're not, having this
Yeah.
or causing this, business as usual model to keep going. We need to change the model.
You're right. Or maybe have like kind of advisory board, like having like a helicopter view that maybe, for example, it needs to be, I think, formed by really serious people, in terms of even researchers, even the stakeholders, even politicians, from the government. So I think it's really important. What is about the public perception about this area? So maybe there could be some ethical questions about engineering natural system, enhancing natural. It could be like doping, maybe natural systems. Is there any kind of wave of thinking about people that are a little bit, against, ocean alkalinity enhancement or not? You can see most of now at the moment society is not fully aware about these experiments.
I mean, there's definitely a massive lack of knowledge about the fact that this is actually happening. But for example, OceanNETs, this project that I mentioned earlier that started in 2020 and it just recently finished, they funded anthropologist groups, social sciences groups, and there was a work package centered around the idea of understanding if you went to the public sector and you told them, like, this is what we want to do, what the response was. And it's actually not very welcomed, right?
Yeah.
In fact, I have this feeling that they started using negative emission technologies, but the word technologies sounds very artificial. So now they're moved to the carbon dioxide removals, right? So it's all about how you explain it as well. So apparently, the public also respond very differently depending on how you explain this.
Yeah.
But of course, I understand that they're reticent to letting people dump, a lot of stuff into the ocean and alter natural processes. But bear in mind that these processes are very highly altered already.
Yeah.
And at the end of the day, the goal is to try and survive and stabilize the climate. Anything that can get to that will help humanity. And we are doing, I'm in the side of things I'm in the side of the environmental impact assessments. This is not something that you can implement if it has a massive impact in the community. And at the end of the day, as I mentioned earlier, this is the goal is to simulate a natural process. So in a way, we're using natural compounds, dumping them into the ocean, while before making sure that they don't have an impact.
Okay.
So I think that as long as the public is involved in future implementation scenarios, and it's explained properly using the right language, I think it shouldn't be a problem. But I might be wrong because I also understand the other side, So
and I think like these kind of discussions, we ended up at the same, corridor, like maybe dead end. And maybe I think we as researchers, we are living a kind of a bubble, an academia bubble that this is not really fully integrated into society. So maybe just trying to get across ideas to this society needs to be more refined. I think we are not really fully aware about the importance about dissemination of our scientific knowledge, how to get these people that have on the technical level or even professional level to get to understand, what we're doing, and putting in clear, concise, and clear language. I think there is a gap there. This is one of the reasons of this blog, this podcast, that we would like to fill these gaps of knowledge about that one, just trying to interact, the connections between academy and the public society. And maybe there could be another figure that need to help researchers to do that. Maybe it could be journalists, maybe it could be, outreach, people focus on outreach of science and this kind of stuff. So
definitely.
That's one. What about looking ahead? What is the next, pilot projects or maybe policy projects that are going to be with this technology? Are you aware about that, or are you involved in that?
Yeah, as I said, we have a new experiment now in a couple of weeks.
Fingers crossed.
Yeah. No, they're coming. It's gonna work. So one of the key aspects of this technology that needs to be studied is that. So as of right now, at least for the experiments that I've been involved in, we've done simulations we've not used the raw minerals, right?
Yeah.
I could get into that, but it's just very technical,
It's
like
technical.
it doesn't matter. But
Right.
what they're doing now is just use the raw minerals pulverized and add them to the water column. That has a set of separate risks that we're testing. So that's one side, like actually looking at what the effects of the raw mineral particles in the water column, what that causes. And what are the best minerals, right? What minerals can we use and have the highest potential dissolve, like have the kinetics dissolve well, right? The ones that are more suitable, that contain elements that are not, that don't cause changes to the biology, like silicate, for example, or like avoiding silicate, like silicate can cause diatom dominated communities, so you can cause shifts in areas where, you know, you usually wouldn't have diatom proliferations. I don't know. So choosing the right mineral is one of the key aspects of this field, of this technology. So that's what they're working on my side, at least, on the German side. Then we have, there's a researcher at the Woods Hole Oceanographic Institute in Massachusetts who just got funded for a field trial. So that's the real next step. So we went from models to laboratory, to mesocosms, and now we want to do field trials, which means a lot of permits, you know, a lot of public, you know, like the public meetings. I don't know how they're called, like where you ask, you know,
people,
involve public sector, involve environmentalist organizations, you know, everything. And that there's the Loch Ness project, it's called, I love it, of Adam Subas. He got funded to do a field trial in Maine. And there's there's a field trial, if I'm not mistaken, in Halifax that they were doing in Canada, funded by Ocean Alkaline as well. There's another startup, Planeteers, in Hamburg.
My God, they're moving so fast. You know, these are the private sectors. You know, the spin-offs are, you know, racing so high. Yeah.
Definitely. Like a close collaborator of ours, Jens Hartmann from the University of Hamburg. He started with a couple of other researchers, Planeteers, a startup that basically they're building a prototype to implement ocean alkalinity enhancement in an equilibrated way, in the way that I mentioned earlier, where you capture CO2 before, so it has more neutral impacts on the carbonate chemistry in situ. So they're working on a prototype to do that in like a reactor. I don't know, there's a lot of work. Planetary Technologies is a big startup as well that are doing work in Canada and wanted to start a project here in Spain because they're using magnesium oxide. No, not oxide, hydroxide. Hydroxide.
Hydroxide,
no.
okay.
I'm not sure.
Okay.
Now I'm not sure. No, because brucite, whatever. They're using magnesium oxide. The mineral that they need, it's being mined here in Spain.
Okay. So,
in the north of Spain. So what happened was that when taking into account the emissions from transporting all that mineral to Canada, you know, when you do a cycle assessment of this, because you want to have, if you use raw minerals, you want to be mined right there. Because otherwise you have to add the emissions from transporting all that mineral to wherever you're implementing ocean alkalinity enhancement. So they wanted to start a project, like a field trial or implement ocean alkalinity enhancement here in Spain. There's a lot going on.
Okay,
there's a lot going on.
And this, just trying to wrap up, you know, and the last question, where do you see, you know, the field of alkalinization in maybe 20, 10 years? Do you think there could be a huge exponential growth? Maybe they're going, what do you feel inside about this topic?
I mean, I feel like it's definitely, like the interest is growing fast. And I think there's going to be a lot of funding, particularly by the private sector.
Okay.
I think.
Okay.
I don't know. I know a lot of people in this field, and I'm happy that most of them are very much about protecting natural cycles and natural communities. So that's there. So I'm hoping that while the funding is, there's a lot of private funding as well as public, and there's, I think, going to be a growing, I don't know if exponential, but fast, quite quickly. It's going to grow quite quickly, I think, the interest in developing this technology and many others in the near future, for sure. I'm glad to say, or at least I'm happy that there's a lot of people in this field as well that are very much about not letting this get out of control.
Okay, sounds good.
So, yeah.
Yeah, very nice. Thank you so much, Laura. Would you like to, ask him something else about any ideas or whatever? Or maybe you are waiting for the next, for the next episode of the podcast.
I'm definitely going to be waiting for that episode.
Okay,
Can't
cool.
wait already.
Okay, so thanks a lot, guys. Here's we ended up to the 6th episode of the Blue Shift, and please follow us in Instagrams. We got the account It's the Blue Shift. So see you in the next episode of the podcast. Thank you so much for being there.